Good morning, everybody. Afternoon. Sorry, we've ticked over to the afternoon. I'm starting off on a good footing here. Good afternoon, everyone. Welcome to this webinar, the latest in our outcomes project outcomes series, which is focused today on human size variation in the design of Australian transport systems. So I'm pleased to bring this project to you with our partners, Transport for New South Wales, Victoria Department of Transport and Planning, the Australasian Centre for Rail Innovation, and the University of South Australia. So firstly, I'd like to acknowledge the Bunurong people as traditional owners of the lands from which we're running the webinar today, and to pay my respects to their elders past and present, and elders of other communities who may be here today. My name is Jackie. I'm the head of comms at iMOVE CRC, if you haven't met me before, and you might not have done. CRC is the National Centre for Transport R&D, which is now in its 6th year of operation. So we have a wide remit for projects which are all industry and government led. This is just one example of those here today. So housekeeping for the session, Q&A, we have the button at the bottom of the screen. Please use this as we go along if you want to ask questions at any time, and we'll deal with the questions in the Q&A session at the end. And the chat is enabled for panelists only, so please keep your questions to the Q&A. Excuse my hay fever voice today. I'd like to get the session underway and introduce our first speaker today, who's Gareth Hughes, who's the Human Factors Manager, Asset Standards Authority Transport for New South Wales, who's going to give us a little bit of context about the project and how it came about. So over to you, Gareth.
Thank you, Jackie, and obviously just to reiterate and acknowledge acknowledgement of country from whichever land that we're lucky enough to be talking to you today. So firstly, I think I really do need to acknowledge the contribution of Alistair Fennell, whose sort of passion and commitment to this project has really been the driving force. Unfortunately, he can't be with us today for family reasons, but I'm sure if he were, his enthusiasm would be highly infectious, as it was to myself. And over the years, Alistair and I had a number of conversations around, I guess, lack of assurance in terms of the relevance of the data that we were using in our design processes from an anthropometric perspective. And, you know, whilst other countries had the luxury of large scale surveys and things like that, we didn't have that luxury in Australia. So Alistair, you know, did some research and came up with an idea which we all supported, and, you know, basically with the help of some extremely clever people, we've ended up with what I think is a really good project and a really good solution to the sort of problems that we had. So I'll let the cleverer people talk about what they actually did to deliver this project, but in very simple terms, based on some NHS survey data and some very, very clever statistics, we've been able to develop and deliver a publicly available source of data that we feel is much more representative of the population in Australia, and will lead, I think, to better design outcomes for all of the people involved, not only you know, the direct sort of people like staff and operators who are using this, but also the public, in terms of when we use this sort of data to help design around public spaces and things like that. I'd also obviously like to thank all the participants, particularly, of course, University of South Australia, Francois, who I'll hand over to in a second, but also Peter and Alexandra. My colleague, Christina, who really was the brains in the outfit from TF&SW perspective, to be honest, because when I had the conversations with her, as soon as we delved into the statistics, I soon recognized that that was not my domain. I just added a bit of encouragement here and there, I hope, and also to Paul, of course, from NTRO, and the fact that the project obviously was supported by iMOVE and Renee, who really helped keep the project going along. And as I mentioned, I think, you know, through a very highly collaborative effort, there were some hurdles that were identified in the project, and through, you know, a lot of collaboration, a lot of hard work, we overcame those hurdles. And as I said, I actually think this is one of the most successful iMOVE projects that I've been involved in, and that the output from this project will undoubtedly lead to better outcomes and better designs for use within Australia. So I'm not going to take any more time. Let's actually understand what was done and what was delivered. And so I'm going to hand over to Francois, who's going to take you through that. So thank you.
Thank you, Gareth. May I also mention Renee Leeson from iMOVE, who's been the project manager and who has been fantastic. I just wanted to mention her name. So welcome, everybody. So today I will talk about this iMOVE project, where the overarching goal was to build and deliver a representative database of Australians' body size for the general population. This is because anthropometry can be used in design assessment and quality assurance processes, where the idea is a specific design needs to accommodate a certain percentage of the population, and one way to assess whether a design meets the requirements is to test with a number of different body sizes and anthropometries. However, at the moment, as I mentioned, when we started the project, there was no representative database of Australians anthropometry for the general public. There were a few tangential databases, but none of it that we deemed to be usable. So the project was initiated for this reason. We wanted to provide a database that is both representative of the Australian adults and sufficiently detailed in terms of the number of measurements. So with this overall goal in mind, the first stage of the project was a scoping exercise. So here, that was divided in two stages. The first phase was talking to the end users, understand their processes, understand their needs, what tools they use, and so on. So we got a pretty good mix between manufacturers, government agencies, state agencies, and some consultancies. Those interviews were conducted either over the phone or via Zoom. We had a list of themes. We didn't have rigid questions, but we had a list of themes that we wanted to touch on. And in this manner, we were able to collect answers from all the interviewees in a relatively similar manner. The main questions we asked them were, do you currently use anthropometry at all in your job? If so, which reference data do you use for anthropometry body size? And then what's your level of confidence in the data? Do you use digital human models? A bunch of other questions, but essentially those were the main ones. What we wanted to understand was the processes, the role that anthropometry play in design assessment and QA in the transport industry, so that we could deliver a database that is as useful and usable as possible. Summarizing again, what came out of those interviews was most of the time anthropometry and body size considerations was part of a more general human factors role, which meant most people, not all, but most human factors specialists were not necessarily anthropometry specialists. And a second point was the software called PeopleSize, which you can see a screenshot of here on the bottom right of the screen, was by far the most commonly used software for anthropometry reference, much more than anything else. It's pretty used worldwide, in fact, and this software provides reference values for different countries all over the world, where you can pick your population of interest, say Australian male, the body dimension that you are interested in, and the specific percentile that you're interested in. And from there, the software provides an estimate of the body dimension. So it's very usable. The interface doesn't look like much, but it's extremely convenient and pretty user-friendly for non-experts. However, most interviewees mention they have low confidence in the data, as in the actual values provided, because there's no information about the source of the data, which is a big issue. Another thing is, because they are non-anthropometry experts, some interviewees were tentative about how to actually apply anthropometry. How does anthropometry relate to a design dimension? How to avoid pitfalls, etc. Generally speaking, people weren't particularly confident with the way they applied anthropometry. And another point is PeopleSize doesn't consider the extra allowances needed for clothing or equipment, such as personal protective equipment. As a result, what we found was the most common process in the transport industry is, in first intention, try to refer to a standard or guideline, and if you can't find anything, then try to work through anthropometry to come up with reasonable dimensions for design. So those were the main results of the stakeholder interviews, which was part one of the scoping exercise. Part two was having a look around for what's out there in terms of anthropometric data for the Australian general public. So there's a number of different sources. First, there's public surveys or research studies who collect anthropometry as part of covariates, for example. So there is a large number of those studies. However, most of the time, it's a fairly low sample size. We're talking about in the hundreds, a very small measurement set. Most of these studies only report height and weight. And also the target population is often very narrow because of the nature of these studies. So those aren't really suitable for our needs. Again, what we want is one, representative data that has good coverage of the overall Australian population, and two, a detailed data with sufficient measurements, enough measurements. Number two, there was a small study that was called Australian Anthropometry Database, AADBase, that had a good number of measurements. However, it was a very narrow demographic. It was overwhelmingly young females. So again, not suitable for us. Defense, there's been good work in defense regarding anthropometry datasets. There's been two large surveys, one for the Army and one for the Navy. And those have very detailed measurement sets. However, it's only for military personnel. And we know that there are significant differences between defense force and general population. Finally, the National Health Service, which may be the obvious ones. The huge advantage of the NHS. So maybe a bit about the NHS. So it's a survey conducted by the Australian Bureau of Statistics every 4 years approximately. And as part of a much larger survey, anthropometry is collected. So it's a very large sample size, about 20,000 adults roughly. However, few measurements, again, height and weight and waist circumference since 2014, I believe. The huge advantage of the National Health Survey is it is representative of the Australian population as a whole. It has a large sample size. The ABS done an excellent job using multi-stage sampling to make sure the population is representative of the overall demographics of the country, which is a large part of the work done for us here. And the NHS data, the raw data, the individual data, is accessible through the ABS, the Australian Bureau of Statistics, through their own software platform, which is called DataLab. So after scoping all of this, we decided the NHS was suitable in terms of being representative of the population and having a very large sample size. However, we only had 3 anthropometric dimensions. So the goal from here was, 1, to access the National Health Survey individual data, which incurs some administrative burden, and 2, to try and estimate the detailed anthropometric dimensions from just a set of 3 dimensions. For this, there's been work that's been done fairly recently in the US, 2018 and then 2022, where they essentially went through this process. They had on one side the equivalent of the NHS, which is called NHANES in the US, which is a data set with very large sample size, representative of the population, but with very few measurements. Again, very similar to our Australian data set. And on the other hand, a detailed data set with much smaller sample size, but with all the measurements needed. And it's not luck that the US developed this method, because it's often the case in anthropometry. Either you can survey a lot of people, but you can't take a very detailed set of measurements because of time and monetary cost. Or you can do it the other way, have a very large survey, have a very small sample size and take very detailed measurements. So this method, developed by Matt Parkinson and Kumar and Reddy, combines the 2 data sets, uses what they called one nearest neighbor reweighting. I will try not to go into too many details about this. It's essentially the reference data set, so the large sample size one. For each individual in the reference data set, you find the nearest neighbor in the detailed data set. The nearest neighbor is in the sense of the height weight space, or in the case of the US, BMI stature space, which is the same thing really. And then the detailed data set is reweighted proportionally to how many neighbors each individual point in the detailed data set has. Then there's a few extra steps, which they call rebalancing, to make sure the full variability of the data set is preserved. And what this gives is a data set that has the full measurement set, so the detailed measurement set with the representativeness of the reference data set, so the large sample size. They've used it in the US, they validated it. So in their case, they used CSAR as the detailed data set, the civilian, American and European surface anthropometry resource, which is the detailed data set. It was done through 3D scanning, and it provides about 100 measurements for about 1,000 each of male and female, I believe, and NHANES for their reference data set. They performed some validation work. The method works extremely well. The errors in estimating dimensions are very small, even at the extreme percentiles where you would expect the errors to be the largest. So here at the bottom, you can see this is not from us, this is from Parkinson and Reddy, the original authors and creators of the study. The errors in terms of stature are absolutely negligible, well below 1%, even at the most extreme percentile. And for weight, the errors are a bit larger at the very extreme percentiles. However, the mean absolute errors are still well below 1%. So again, this has been used in the US to provide a reference data set. We figured this has been validated. Let's not reinvent the wheel and apply the same to get Australian anthropometry. Pardon me. So this is what we did. On the right here, you can see a summary of the whole processing steps. So we start with the NHS anthropometry. We used the two most recent time points at the time, which were 2014 and 2017. Now 2021 has been released. It wasn't when we started, so we couldn't include it. And the time points prior to 2014 had different measurement protocols, which means we couldn't combine them with the two latest time points. Still, this gave us about a bit over 20,000 individuals with a almost even split of male and females. For the detailed data set, which you can see on the rightmost side here, the red dots, we used CSAR, which is American and European as detailed. I'll come back to this in a minute. First, I want to talk about a hurdle that we encountered is, although we could access NHS individual data through the ABS software suite, we could not use individual data directly because of data privacy concerns. For our method, we needed to have both NHS and CSAR in the same place to run the one nearest neighbor reweighting. So workaround to this is to fit a skew normal distribution to the NHS data. It needed to be skew normal because the weight data in particular is quite heavily right skewed in almost all countries in the world. So we fit a skew normal distribution, and then the ABS let us export the distribution parameters. So we had our distribution, and from there we could sample from it and essentially recreate what we called a synthetic NHS dataset, which then allow us to have both individual data from NHS and CSAR in the same place. And from then on, we run the reweighting method developed by Parkinson and obtained our estimates. This is an overview of the process. Of course, there's a few caveats and a few quality checks and sanity checks we performed along the way. The first one was, how legitimate is it to use CSAR as the detailed data set, because CSAR is American and European, and we want Australian data. So first thing we did is we compared the CSAR anthropometry data to the NHS data. And here what we wanted to figure out is, do we have good coverage between the two? Because to summarize it, the nearest neighbor method tries to find the nearest neighbor for each data set. So if both data sets don't cover each other well, some neighbors will be far and skew the data heavily and provide incorrect results, essentially, or inaccurate results. So first step, check the coverage of CSAR versus NHS. You can see both graphs on the bottom side here. Blue is Australian data, NHS, the reference data set. Red is CSAR, the detailed data set, male and female on the left and right, respectively. And you can see here, we've got respectable coverage. We cover the whole range. The shape of the distributions is very similar for both. We've got a large skew on the heavyweight side, so right skew on the weight data for both males and females. Overall, we were happy with how the two data sets overlapped each other. Decided it was more than appropriate to run the reweighting method on these. Number two, as I mentioned, we couldn't access directly individual data, raw individual data from NHS. So what we had to do was fit a distribution to it and then sample from the distribution to regenerate individual data, artificial individual data, or synthetic, as we called it. So of course, what we needed to do here is check that this process was valid and accurate, that the synthetic data set matched the actual NHS data. So we compared the percentiles. Method worked extremely well. On the top table here is the one of interest. And And the last row of the top table gives the percentage difference between reference or original and synthetic data. Mostly the differences are noticeable on the large weight percentile, so at the extreme right of the distribution, the 95th percentile for weight. We got over % error for females, where the synthetic dataset underestimates weight a little bit. It's the same for male, but to a lesser extent. To us, that indicated that one, even fitting a skew normal distribution, so including the right skew, still wasn't quite enough to represent how skewed the Australian data was. However, the differences were about a kilogram at the 95th percentile. The differences in height were almost negligible and certainly comparable to measurement error. So we were happy with the outcome here. The second thing that we tested was how stable is the sampling from the distribution. So I generated 1,000 data sets because the sampling is done through a random seed. At the end of the day, we wanted to generate one synthetic data set and then perform the reweighting. So it was important that the distribution didn't change if we generated it multiple times. And here we had no issues at all. Even at the extreme percentiles, the generation was extremely stable. We got always the same, essentially, always the same characteristics. So very happy with it. So at the end of the day, the fit a distribution and then sample from it, even though it's a big workaround, generated very similar individual data from the actual NHS. So we were happy with this. And this was the only workaround we had to use NHS. Now, with both our synthetic NHS data and CSAR, we performed the reweighting method. And this is what we got. This is the main course, essentially, I would say, of the project, which is the detailed anthropometry database. So it has as many anthropometric measurements as CSAR, which is 105, with the caveat that some measurements are given left and right. For some measurements, left and right were both measured, so not 105 might be necessarily relevant, but not the majority are. From the phase one, with the stakeholder interviews, we kind of narrowed down this measurement set to about 43 measurements that were deemed important in design. And this is what we present in the main report. We provide the values at typically used percentile, which is the 50th, the median. Then we give the 25th and 75th, which in my experience aren't terribly used. But the 1st, 5th, 95th, and 99th are often of the most interest. So we provide this in tables with, as you can see at the bottom, illustrations to be able to find the required dimensions quickly, a little bit like people size does it. So we did provide a final detailed reference data set for Australian adults, which is what we wanted. We were very happy with this. One thing we did, because the end users mentioned people size was the most used software. However, it's not particularly clear how people size obtains the data. We compared our anthropometry data to what people size provides. What we found was in the middle for the 50th percentile, people size was very reasonable, very close to what we got with our method. However, the more extreme the centiles and the more error people size makes. So you can see here, the big table on the right has a lot of numbers, but the yellow highlighted cells are differences between 3 and 5%, and the orange cells are differences of more than 5%. And as you may see, there's a lot of them at the 5th and 95th percentile, especially for weight and breadth and width related measurements, let's say. And the error always seems to be in the direction of people size underestimates the large percentiles, so you get negative differences, and overestimate the small percentiles, so you get positive differences. So that means to us the people size population estimates at the extremes are too narrow, which is a potential issue because I wrote here errors are in the most detrimental direction. If you're trying to accommodate from a 5th to a 95th male, for example, and use people size estimate, you might end up with a design that actually accommodates maybe the 10th to 90th percentile, a design that's too small for the intended purpose. So to summarize, even though people size in the middle at the 50th percentile is pretty good, at the extreme percentiles, it has significant differences, and the differences are in the wrong direction, quote unquote. In summary, as far as we know, it is the first large-scale, representative, detailed Australian anthropometry dataset. It is, we believe, the next best solution after actually measuring people. It is a lot cheaper than actually measuring people. Of course, doing a large survey of the general population would be the gold standard. However, it's a whole different scale. So we were very happy with the results here. For the time and money investment, we do believe this was the best bang for your buck. The third point is people size provides too narrow accommodation ranges, which is potentially problematic. So here, for future work, we are examining possible options. One would be to integrate data in people size. This has IP issues, and also the fact that people size commercial software, whereas the NHS data is paid with taxpayers' money. Other options for what to do in the future. Children, we don't have detailed anthropometry for children. Children has the added difficulty that they grow up, and so their anthropometry changes very often. So if you want something representative for children, you need to sample, say, every 2 years or something, and it compounds the issues with sample size and so on. However, we are investigating the matter here. It would be very beneficial, we believe, to have a similar detailed data set for children, because in transport, it can happen in things like passenger carriages, where children are actually the boundary users, and as in users that need to be accommodated. So it seems fairly important to look into this. A bit more exploratory, we're looking into new or newish measurement technologies. Now there's incredibly fast 3D scanners using visible light. Essentially, we are scoping, trying to explore ways that we could actually collect large-scale anthropometry data at reduced burden compared to doing physical measurements with meter tapes and calipers. Something we still need to do, the last point, is actually release the full data set in a user-friendly manner. At the moment, it is Excel spreadsheets. What we're looking to do is to have something interactive, which will make it a lot more usable. So that could be, as I mentioned earlier, possibly through people size directly. For the end users, this seems to be the most efficient way. Essentially, they wouldn't have to change any of their processes. However, the issue with public data in commercial software is there. So that concludes it. And I believe it's time for Q&A. Thank you, everyone.
Thanks, Francois. Great work there with that presentation. So you've done most of the heavy lifting for us, which is fantastic. Just to kick things off, we have got a few questions coming through the Q&A at the moment, so I think we'll tackle those first. So keep them coming. If you can get them through, that would be great. But we'll start with the Q&A from Marilyn. Are you confident your results reflect the size or proportion of the Australian population represented by the diversity of ethnic groups and that make up the population?
That's such a great question. We actually spent a fair bit of time thinking about this. I don't have video anymore. That's okay.
Mm.
The short answer is we trust the ABS and their sampling method. The ABS reports that their sampling is representative of geographical location, ethnicities, so on, so on.
Mm.
So it was the huge advantage in using NHS is all the sampling work has been done for us. Having part of this kind of large studies where we try to get sample strategies where we want representative data, it is a bit of work. So yes, we do believe that we have taken into account the ethnic diversity, but we have taken it from the ABS. A second part of the answer, sorry, it's a long answer. We did some digging up, some scoping of the literature because we investigated what are the differences in anthropometry between ethnicities within the same country, right? We know that there's differences between, say, Chinese population, Brazilian population, Australian population. However, what we're interested in is ethnicities living in the same country. So we need a lot of digging, and it's a fascinating topic. I'll try to keep it short. Most of the results come from the US, looking at white, blacks, and Hispanics. There are significant differences in anthropometry. That's for the US. However, if you remove socioeconomic status from the equation, these differences disappear. Essentially, it seems to mean that socioeconomic status is the determinant, and different ethnicities have different average socioeconomic statuses. So that seems to be the difference. One more thing is in the US, at least the migration of blacks was a long time ago, let's say, relatively to migration in Australia of, say, Asian populations. So this is the highly speculative part where we don't know the timescales of the homogenization of anthropometry, so to speak. We did the best we could with our scoping. We know that there are differences in anthropometry between ethnicities within the same country. We have some idea of the extent of them. We don't have an exact response for Australia. We trust the ABS with their sampling. Thank you. Hope that answered the question.
Thanks, Francois. Did anyone else have any comments to add to that particular question? Or we can move on to the next one. Okay. I might ask, we've got a question from Karen West. Karen, if you'd like to put your mic on and give us your question in person, you're welcome. I can see you put your hand up. Otherwise, I can read out the question that you've sent through.
Yeah, up to you. I'm happy to read it if you want to.
Okay, well, we'll read the question. I wonder if there's currently or could be in the future a way to review data in subsets of the population. So this is moving on to other subsets, looking at mobility aids and possibly Aboriginal and Torres Strait Islanders. So a bit of an extension on what you were talking about.
Yeah, it is. Look, absolutely. There would be hopefully a way to review this data. One thing about the ABS is they did not cover what they call very remote locations, capital V, capital R, so Aboriginal communities aren't covered, which is an issue, of course. It is difficult to sample there. Hopefully this is something that can be covered, absolutely. In my opinion, the best way to do it would be an actual survey, as in measuring people. Yeah, it would be interesting. I mean, my experience, it's always a balance of bang for buck, right? Money is limited, time is limited, so we have to set the priorities however we can. At the moment, my thought would be getting data on children would be massive benefit, but there is always space for indigenous people, Aboriginal, Torres Strait Islanders. Second part of the question was mobility users. Absolutely, it's a huge point, and we did discuss it with Paul, with Christina, with everybody. The same way children can be the boundary users, wheelchair users can be the boundary users. It's something we intended to cover at the start of the project that we didn't cover in the end. There wasn't enough time, but it should absolutely be done. Agree. I can't answer more than yes, it's very important. No, we haven't touched on it.
Okay, thanks for that answer, Francois. So just moving on to some of the other questions coming through, the practicalities of using the data set. So I've got a question here about what are the first steps that you should take to take the research or the study and apply it to legacy fleet and cab design issues. So where do you start? Where do you start with that on a practical level? Anybody can tackle this. It's Francois doing the heavy lifting here, but if anyone else has got a comment, please feel free to chip in.
You're muted, Gareth. Gareth, you're muted.
Gareth, you're muted.
Thank you. I was answering to myself very nicely there. Sorry. I think the first point is, what are you trying to find out? What question you're trying to answer? Realistically, within the constraints we've got within fleet and cab design, trying to make an accommodation to, let's just say, one measurement can often have a highly interactive effect on lots of other measurements, and trying to accommodate that within existing design can prove very expensive. So unless, for example, the fleet is coming up for a major renewal or refurbishment, then it may well be difficult to actually make any changes. However, there may be some, and realistically, I guess the thing to do is really to try and identify what the actual current measurements of the fleet are, what the design parameters were at the time, and then compare them back to the data, and make a judgment on sort of the cost benefit of any potential improvements that you could make. I'm also going to be a little bit cheeky and answer the next question down, which is around how should infrastructure design respond to this data? And there's a very simple answer for that, is that we should be looking at the new data as the boundaries of our design parameters. And where possibly, we should be accommodating that. A lot of the time for example, in rolling stock design, we do have significant constraints on the amount of space we've actually got, but that does not preclude us from trying to do the best we can and applying this new knowledge in terms of trying to accommodate that somewhat wider range, and using the results of the study and design to improve things. So, hopefully that's answered that question too.
Thanks, Gareth. That's great. And I can see it might be a good time, actually, with you mentioning the rolling stock there, just to throw over to Paul, who from the Australasian Centre for Rail Innovation, and Paul was involved in the project throughout. So I can see we've got quite a few rail people who are on the webinar today. Paul, did you have any comments you wanted to make about that?
I guess just from perspective when this project was being formulated and I guess built together and circulated with the wider rail industry stakeholders, one of those sort of key outcomes that Gareth touched on at the start that everyone was really keen to understand was to have a updated, in terms of currency and timescale, to the available human-sized data. So that, and I believe that's been done. We're now at a point where we've significantly moved that forward. And yeah, as Gareth just touched on, it is really over to the planning, the design, the procurement users of the rail industry to think about how they can use this. And as Gareth almost took the words out of my mouth in terms of the infrastructure design response to actually now use what we've got in terms of information as a new baseline. And of course, there will always have to be compromises, but then particularly where we talk about the retrofitting of the existing rolling stock. This might allow us to think about other treatments that we haven't, mitigations that we haven't considered in rolling stock design. So it might be passive treatments that, we can't physically change things in terms of seating with the kinematic envelope we've got, but can we put in more handles at the right locations to suit a greater range of our users? So, and yeah, quite interested to see with the technology side of things where else we can use this data now we've got it, because it was very much focused on rolling stock interior, driver cab, station platform applications. We're in our sort of early periphery, but there's lots of other applications that we should also consider now that this is updated.
Thanks, Paul. Some good insights there. And I think that probably responds to Taru's question that came through about the infrastructure design there as well. Just going a little bit more into a bit more detail on the nature of the data. Francois, there's a question come through about the differences between the data of people size and yours. Can you expand a bit more on that topic?
Sure, yeah. So people size is proprietary software, it's closed source. So to preempt the answer, all I can do is speculate. The way people size work, you can do a bit of reverse engineering playing with it. And essentially, it's certain that people size uses a distribution and then generates the percentiles based on some parameters. Just because you can select any percentile, 98, 97, so on. So they do use some form of distribution. That's one thing we know. They do have some inclusion of skew in the distribution. That's absolutely certain. When looking at the comparison with people size, even though there's large differences at 5th and 95th, I also had to play with an unskewed distribution. And as expected, it's absolutely horrible. Massive underestimates at the high end, massive overestimates at the low end. So we know they generate percentiles from some parametrization or distribution. My best guess would be it's just a matter of turning the knobs, like some parameter estimates are slightly off for them. But I don't have any more precise answer on this, because again, all we can do is try and understand a bit and reverse engineer people size, but we don't actually know how it's calculated.
Thanks, Francois. Just thinking about the data, was there an opportunity to actually export from ABS data and use that data set? Obviously you've created all of this. What was the reasons for going down the route that you did?
I'm getting PTSD from this question. Okay, so the ABS has fairly strict data privacy. So we can access individual data in Data Lab, which is their secure environment through virtual machine. We can do this. That's how I got the percentiles out. However, we cannot export individual data. We tried to ask them, can we just please get age, sex, and anthropometry? They said no. Fair enough. They're concerned with privacy. So then our next idea was, well, we will import CSAR data, so our detailed data set, we'll give it to you, we'll put it in Data Lab. So then, again, the idea, what we needed is the two data sets in the same place. We said, okay, we will import CSAR in Data Lab, do all the reweighting. It's a bit painful, having to code on a virtual machine and so on. And then we'll export the results. After we went through the whole process, we asked you request for output clearance of the data once you're done doing your thing in ABS. We asked for output clearance. We thought, CSAR doesn't belong to the ABS, even though it's individual data. They said no, so we didn't get clearance. So it turns out the moment individual data touches Data Lab, so to speak, then it cannot come out anymore. No individual data comes out of the ABS system. I hope Paul and Christina are doing it justice. So I forgot your question by now. I just wanted to say, of course, it would have been better, just using individual data from the ABS. of course, because this goes through, fitting a distribution and then resampling from it, which is strange. However, that was the only way we could achieve our objectives. And we were pretty scared for some point in the project when we got denied, trying to get the data out both ways. We didn't know what to do. So yeah, and of course it would be better. That being said, I'm going back to that slide with the distribution. Fitting and resampling, essentially, the error is negligible compared to everything else. All right, so we're pretty happy with it.
Yeah, congratulations on getting the result that you did with all the challenges that were thrown at you in that regard. We did hear about them as it was unfolding, and you did well to get the results. So just moving on, we've got time for a couple more comments. In terms of what's going to be available to people, there were 105 measurements. Are these all going to be available or to the public, or how's that going to work?
Yeah. 105 measurements, every percentile. Yeah, that's so. This one, in first instance, will probably be a massive spreadsheet. So we are aware that it's not the most user-friendly. However, all the data is there.
Yeah.
At the moment, what we have is a spreadsheet with 105 measurements and the weightings, which isn't really user-friendly. You have to essentially reweigh manually, right? Do your percentile with the weighting. So as a temporary solution is to provide 105 measurements times 99 percentiles. Yeah, that's right, first to 99, and then you can dig through it. In second instance, the plan would be to have something a little bit more interactive, whichever form that may take. It might be, Excel macros, might be something a bit fancier. We are just now figuring it out, pretty much. But yes, you can have the whole measurement list, absolutely.
Yeah, that's great, thank you. Just another comment popped through at last minute. The downloadable report. Scott, thank you, you're here. The downloadable report is available. I popped it in the comments, but it's now in the Q&A as well. Sorry, I can't read and think at the same time apparently, but so please have a read of that. And the research team, obviously, if you've got any commentary that you want to get back to them, we're happy to provide that. But I think all in all, thank you for your efforts, Francois, in particular, for presenting to everybody today and doing the heavy lifting with a lot of the questions as well. It's a very worthwhile effort. Clearly, it's becoming increasingly important that we, always important, but increasingly important that we design for our population that is relevant and fits now and into the future. And this is an important piece of work in that regard. So I'd like to say thank you for a successful project through iMOVE, and thank you for participating in the webinar. Also to Gareth and to Paul and to Christina for supporting the webinar as well. And we look forward to seeing what comes next. So thanks, everybody. I appreciate your time today, and watch out for the next in this webinar series of project outcomes from iMOVE. Have a great day. And for those of you in Victoria, have a great long weekend.
Thanks, Jackie. Can I just thank iMOVE in general, the iMOVE CRC. It's been fantastic. We've had a few bumps along the way, and iMOVE and René have been great. It's been very pleasant and very effective working with you guys. So thanks to the whole team.
Beautiful. Thanks, Francois. Glad it was a good experience. Have a wonderful weekend, everybody.
Bye.
Thanks, Jim.
Right, thanks.
That's all. Bye.